One of the things we talked about in chapter 4 with scatter plots is that once we have the direction, either positive or negative, we can write a sentence that interprets that direction in context of the word problem. So here we have this example with a temperature in the ice cream sales again. And so to interpret this one in context, my statement would be something like, as temperature increases, ice cream sales tend to increase as well. So a natural question might be, now that we've moved from just looking at the dots to fitting an equation to them, once we have that equation, could we write a better sentence than the one we've been writing from chapter 4? And the answer to that is yes. So that sentence that we're going to write is tied to the slope. And the slope, we represent with that letter M, and it's always the number that's attached to X or to the explanatory variable. Okay, so the value of slope is just that number. And then to interpret it, you're going to say as the X variable, and you'll replace the X variable with whatever your explanatory variable is or what's on the X axis. So as that X variable increases by 1 unit, the Y variable either increases or decreases by the slope value units. So if my slope is positive, I'll say my Y variable increases by whatever that number is with some units on it. But suppose my slope was something like -5. Then I would say my Y variable decreases by 5 units. So I'll take that negative sign off because I'm using the word decreases when I write my sentence. All right, so let's look at how to do this with our ice cream sales example. So our equation was y equals 33x minus 216. So our slope is the number attached to the x, which is 33. And so my sentence is going to be as the temperature, that's what my x variable is. So as the temperature increases by 1 degree Celsius, ice cream sales increase by $33. So each time that temperature goes up, our predicted sales increase by $33. All right, so that's one of the two numbers that's in the equation. The other number is our intercept. So the intercept, this is the y-intercept. So if you think about an axis or a set of axes, this is where your line is going to cross the vertical or the y-axis. So this is when the explanatory variable x is equal to 0. So my sentence is going to be when the x variable is 0 units, the y variable is, and I'll put whatever that intercept is and put some units on there. So again, with our ice cream example, here we see that our intercept is -216. So if I write this sentence out using that number, I'll get when the temperature is 0 degrees Celsius, ice cream sales are -$216. So that would be the interpretation. Just I filled in all the blanks, and that is a correctly written statement interpreting the intercept. But the question you have to ask is, does the sentence even make sense? Or in statistics, is that intercept even statistically meaningful? So statistically meaningful means, does this actually work in the real world? Does this have some common sense, real life meaning to it? And in this case, you can't really have negative sales. So I would say that no, this is not statistically meaningful. That sentence doesn't make a lot of sense. Okay. Typically, this happens when that value of 0 falls in the extrapolation range. So remember, when we looked at this earlier with extrapolation, we said the smallest value we'd probably use this with was about 11 degrees. So that puts 0 over where extrapolation is happening, and that's often the reason why that sentence doesn't make sense. But you should always read that sentence and decide, does this make sense in the context of the problem or not? All right, come back in the next video and we will do some practice with this.